Welcome to the deep dive. Today we're looking into a really interesting idea, one that could genuinely change how kids learn. Imagine kids not just, playing games or watching videos, but actually making things, designing their own animations, maybe even building simple games themselves. So this deep dive is all about a vision for a new kind of educational model. It's about shifting things, moving from just soaking up information to actively creating. And it starts with something that sounds pretty simple: numbers in a grid. Our mission today is to explore how this, seemingly small idea could spark a much bigger change in how children learn, create, and connect with the world around them. You might find yourself thinking, wow, I wish I'd had something like this. Okay, so let's get into it. The core idea starts with the design tool for kids, using numbers in a grid, like a matrix, to make patterns, maybe logos.
Exactly. And the clever part is the mapping. Numbers, say 0 to 10, don't just stay numbers. They map to fun symbols, maybe emojis. So like 0 could be a little O, 1 a dot, 2 maybe a lightning bolt, 3 a triangle coup, 5 a heart noter, 10 a nice QB. You get the idea.
Okay, right. So it's visual instantly. It's like pixel art meets a secret code or something.
Precisely. And what's really fascinating, educationally speaking, is how it introduces some pretty big concepts: arrays, coordinates, patterns, but in this incredibly playful, accessible way, even for really young kids.
Can you give us an example, like a really simple one?
Sure. Imagine a tiny 2x2 grid. The child puts 0, 1 in the top row, and 2, 3 in the bottom. Instantly they see O, dot, lightning bolt, triangle. The abstract idea of a matrix just becomes tangible, fun even. No scary math terms needed.
That makes sense. And I read the source materials suggests going even further than that, making it bigger.
Oh yeah, definitely. You could extend the mappings, maybe up to 20 symbols, let kids choose their own. 11 could be a star, 12 a balloon, the 13 a unicorn sea, you name it. Pizza, why not?
Customization, right? And what about shapes? Are they stuck with just rectangles?
No, and that's another really neat part. The idea includes using blanks or transparent cells, maybe represented by a special value like equals 1 or just null.
Ah, so you can make shapes that aren't just solid blocks.
Exactly. Think about making a heart shape. You'd use the number for the heart symbol, say 1 for Sorrow, and then surround it with these blank cells. So the matrix might look something like 1, 1, 1 for the top row, then 1, 1, 1, and so on, visually forming that heart.
Okay, I see. So it's not just pattern making, it's also about spatial thinking, designing within constraints, but it feels like play.
That's the key. It feels intuitive. Kids are grasping complex ideas visually without feeling like they're being taught something difficult.
All right, so we have these cool static patterns. How do we get them to, move, bring them to life with animation?
Yeah, that's the natural next step, isn't it?
Yeah.
And the approach here is beautifully simple. Frame-by-frame animation. Think of a classic flip book. Each matrix the child designs is basically one page, one frame in the animation sequence.
Okay, so you just make several slightly different grids in a row.
Exactly. And the interface for this needs to be super minimalist. Big buttons, Preview frame, play, pause, maybe a fun speed control slider. The source material even suggests labeling it whimsically, like from a turtle speed up to a rabbit edges speed. Helps kids grasp tempo.
Huh, I like that. So we're not just making pictures, we're making them dance. Let's take that heart oka example again. How would you make it bounce?
Simple. Frame 1, heart on the left side of the grid. Frame 2, heart in the middle. Frame 3, heart on the right. Play those frames quickly, one after the other, and boom, the heart looks like it's moving across the screen.
It reminds me of that quote from Norman McLaren, the animator, something about animation being the art of movements that are drawn.
That's the one. Animation is not the art of drawing that moves, but the art of movements that are drawn. It fits perfectly here.
And that instant feedback, seeing your creation move right away, that must be huge for keeping kids engaged, right?
Absolutely paramount. They see the direct result of their choices immediately. Click, drag, play, it moves. That cause and effect loop is incredibly motivating. It shifts them from just watching things to actively making things happen.
Okay, this is where it gets really, really interesting for me. The idea of not just making the animation, but actually seeing the code behind it.
Yes. This is, I think, the most potentially transformative part. It's about bridging that gap, connecting the intuitive visual side with the logic of how computers actually work, computational thinking.
So how would that look in practice? An app with two sides?
Kind of. Imagine an animate and code app. You've got your visual design mode, dragging emojis, setting keyframes, all very intuitive. But then maybe there's a toggle switch. Flip it, and you see the code mode. It shows you the actual lines of code that your visual actions just generated.
Wow. Okay, let's use a turtle solve. A kid puts a turtle on the left, sets a keyframe, moves it to the right a few frames later, sets another keyframe, plays it, turtle moves, then they hit the toggle. What code pops up?
It would be simplified, of course, but real code. Maybe something like turtle emoji to define the character, and then a line like turtle.movefrom, x0, doxa 100, duration 2.0. Something clear, readable.
And maybe features to help, like colors highlighting parts of the code.
Definitely. Syntax highlighting is crucial. Maybe preloaded characters to start with. And the source even mentioned voice narration. Tap on a line of code, and it reads it out loud, explaining what it does.
That's incredible. It's like lifting the hood on the car. You see how the engine works?
Exactly. It demystifies technology. Kids realize it's not magic, it's instructions. Instructions they can learn to write. It turns them from just users into potential creators.
And the educational value there must be huge, pulling back that curtain.
Immense. They start understanding core concepts without even realizing it sometimes. Sequencing things happen in order. Variables, the turtle's a variable. Maybe simple loops later on. Event handling. It builds on the legacy of tools like Scratch, or even way back to Logo Turtle.
It makes me think of that Maria Claw quote, something about coding being the language of creativity.
Yes. Coding is today's language of creativity.
Yeah.
All our children deserve a chance to become creators instead of consumers of computer science. This approach directly serves that goal. Seeing the code empowers them.
Okay, so this sounds amazing, but maybe a bit daunting for parents or teachers thinking, how do I even start this? Are there existing tools that kind of pave the way?
Oh, absolutely. And that's the good news. There's a whole ecosystem of tools out there that already embody parts of this philosophy. We don't need to invent everything from scratch, so to speak.
But what? What's already available?
Well, you've got Scratch and Scratch Junior. Fantastic for younger kids, maybe 5 to 10.
Yeah.
Very visual, block-based. Great for animation, though. Maybe a bit tricky for these 2D matrix things sometimes.
Right. Block coding.
Then there's Tinker. Also starts with blocks, but cleverly transitions kids towards actual text code like Python or JavaScript as they get older. They have specific animation courses, parent dashboards, really well thought out.
Okay, so a smoother transition path.
Yeah. And for slightly older kids or teams, Thunkable is interesting. It's more of a no-code app builder, but it lets you see and even export the underlying code. You could build custom animation logic there.
And Codable. I think I saw that mentioned.
Codable is great for the younger end, maybe 5 to 10 again.
Yeah.
It actually shows real JavaScript code alongside the drag-and-drop interface. So kids see that connection early on.
So these tools show there's a path. But the vision we're discussing seems to want to unify these steps more intentionally.
Exactly. It takes inspiration from all of them, but aims to create a more seamless, integrated journey. From that first playful matrix design all the way to potentially writing real code within one kind of environment. And critically, making that code connection explicit early on.
And making it engaging, right. You mentioned gamification earlier. How would that work? How do you turn this learning path into something kids want to do?
Well, you borrow principles directly from game design. Structure the learning as a series of, say, quests or challenges.
Like animate the bouncing heart.
Sort of, but maybe more involved. Animate 3 turtle jumps over barrels. Successfully doing that might unlock the next level, or maybe it unlocks the ability to see the code for that specific challenge.
Ah, so the code reveal itself becomes a reward.
Exactly. You tap into game mechanics like development and accomplishment, earning badges, leveling up skills, getting certificates for mastering animation types. And empowerment of creativity is huge here. The core activity is creative expression. Plus, unpredictability and curiosity may be revealing hidden code snippets or bonus symbols after completing a tricky challenge.
So a clear progression, beginner to advanced.
Definitely. Start with simple movements. Then introduce obstacles, timing challenges, jumps that's intermediate. Then move to advanced, maybe requiring simple conditional logic if-then statements, eventually leading towards text-based coding for more complex scenes. It makes the learning curve feel less like a chore and more like mastering a game.
It really does sound like more than just an app or even a curriculum. It feels like a whole philosophy of education.
You've hit the nail on the head. It's envisioned as a hands-on constructionist model. Remember Seymour papered, learning by making. The child isn't a vessel to be filled. They're an active builder of knowledge.
And the creator is right at the center.
Right at the core. And it's built on several pillars. 1, the child as an active physical creator. 2, not just screens, using styluses, maybe storyboarding on actual paper first, even building prototypes with crafts.
Connecting digital and physical. I like that.
2, it has to be interdisciplinary, project-based. Subjects shouldn't live in silos. That animated ecosystem idea, it touches science, art, math, language all at once,
Makes learning more relevant, I bet.
for sure. Third, technology is an integrated toolkit. The Matrix tool, drawing apps, coding windows, physical materials, they all work together seamlessly.
Not just tech for tech's sake.
No. And fourth, visible progression, that gamification we talked about. Maybe even physical skill trees posted in the classroom. Kids move their markers, they master Coordinate Wizard or Animation Ace.
Huh. Love that. And the fifth pillar.
Authentic audience and impact. Kids don't just make things for the teacher, they share their work. Maybe class film festivals or setting up an interactive museum for other classes or parents. Gives their work purpose.
Okay, let's drill down on that interdisciplinary point. How easily does this matrix tool, for example, weave into different subjects?
Surprisingly easily, actually. Language arts. Kids design characters, then animate scenes from stories they write. That hits narrative structure, dialogue, everything.
Okay, obvious fit there. What about art?
Well, that's natural too. Digital pixel art, logo design, exploring patterns, color theory through symbol choices, the animation principles themselves.
Math. Seems like a good fit too.
Absolutely. Visualizing coordinates is the start. But think about transformation scaling, rotating patterns. You could even visualize multiplication tables using emoji patterns.
Oh, interesting. Social studies.
Animate key historical events. Design and animate cultural symbols. Create timelines that move. Model processes. A simple one could be states of matter. Use the ice cube as symbol, animate it changing to a water droplet, then to a puff of steam, or model simple life cycles.
Wow. It really can touch everything. It makes that Yeats quote, "Education is not the filling of a pail, but the lighting of a fire," feel very real.
It does, doesn't it? When learning is integrated and creative like this, it naturally becomes more engaging and, frankly, more meaningful for the child.
This whole vision feels so necessary, so modern. Are there places in the world already doing things like this? Are there real-world models that show this kind of education works?
Yes, and that's really encouraging. This concept doesn't exist in a vacuum. It resonates strongly with innovative models we're seeing internationally.
Like where? What kind of models?
Well, think about Finland. Their phenomenon-based learning is all about interdisciplinary projects, tackling real-world topics, not just separate subjects. Teachers there are more like facilitators.
Right. Finland often comes up. Anywhere else?
Colombia's Escuela Nueva model is fascinating. Very active, collaborative, self-paced learning, often using hands-on materials tied to the local community. Singapore is a leader in integrating computational thinking right from the start, often using playful, game-based approaches with tools like Scratch.
Okay. Any others?
The International Baccalaureate's Primary Years Program, IBPYP, is built around inquiry and transdisciplinary themes. Kids often create digital projects as part of their learning. There's even a program called Can't Wait to Learn, used in places like Sudan and refugee settings. It delivers game-based learning on tablets, proving this can work even in really challenging contexts.
Wow.
And Poland has also made significant curriculum reforms, pushing towards project-based learning, critical thinking, and creating digital artifacts.
So it's not just a pipe dream. These models are out there working. What's the common ground between them all?
You see clear threads. Active, hands-on learning is central. Technology is integrated thoughtfully as a tool for creation, not just consumption. Learning cuts across subject lines. The teacher's role shifts to facilitator and guide. And crucially, there's a deep commitment to equity in reaching all learners.
Seeing these examples really adds weight to the idea, doesn't it? It shows this holistic, creator-focused approach is achievable.
It really does. And it brings us to perhaps the biggest point, this whole discussion, this vision. It's more than just pedagogical preference. It feels like an urgent call for change.
A revolution in learning, as you put it earlier.
I think so. Especially after the pandemic, which just threw the massive inequities in global education into such sharp relief. We saw systems break down. We saw millions left behind. We simply cannot afford to just drift back to the old normal. We have to build something far better, far more equitable. And that requires rethinking the foundations.
So what are those foundational pillars for a truly modern system?
Based on the sources in current global dialogues, I see 4 critical pillars. First, technology integration, but done right. Not just swapping a textbook for a PDF. We need to aim for transformation, using tech to enable new kinds of learning, new kinds of creation, but always human-centered. I love that quote from Susan Hopgood, president of Education International.
What does she say?
Education technology solutions that are teacher-free are always designed for other people's children. It's a powerful reminder that tech should empower teachers and students, not sideline them.
That's sharp. Okay, pillar 1, Transformative, human-centered tech. What's two?
Pillar two has to be equity and inclusion. This is non-negotiable. We have to tackle the huge diversity gap in teaching staff, like in the U.S., where it's so mismatched with the student population. Globally, think about the nearly 100 million kids out of school just in sub-Saharan Africa, or countries literally spending more servicing debt than educating their children. Hopgood also said, today hundreds of millions remain excluded from education. We have to address that exclusion.
So systemic inequalities are central to this reform. It's not just about the classroom.
Absolutely not. Which leads to pillar three. Teacher support. We have a massive global teacher shortage. Estimates are around 44 million needed. You can't fix education without supporting educators. I mean, fair pay, yes, but also high-quality professional development, real mentorship, training in things like anti-bias practices. Teachers need to be, as the global union bodies say, at the heart of decision-making about education.
Makes sense. Empowered teachers lead to empowered students. And the final pillar.
Pillar four is curricular innovation. Moving away decisively from rigid, siloed subjects towards that interdisciplinary, phenomena-based learning we see in places like Finland or the IB. The focus needs to shift strongly towards skills like critical thinking, collaboration, creativity, and especially media literacy. In today's world, well, Maria Ressa, the Nobel laureate, nailed it. The end goal of disinformation is chaos. Education must equip kids to navigate that. And let's not forget emotional intelligence.
Wow. Okay, those four pillars, tech integration, equity, teacher support, and curricular innovation, paint a really comprehensive picture of what's needed. It's clear this isn't something schools can do alone. It needs governments, institutions, communities, everyone pulling together. What a fascinating journey today. We started with a simple grid of numbers and symbols.
Yeah, that little matrix tool.
And ended up mapping out a vision for a truly modern global education system. One that's integrated, gamified, globally informed, and fundamentally about empowering kids to be creators.
It's about shifting from passive consumption to active creation right from the start.
Exactly. It really makes you think.
If I could leave our listeners with one thought, it goes back to that Yeats quote we mentioned. Education is not the filling of a pail, but the lighting of a fire. The question for all of us then is, what are we actually doing today, right now, to ensure that every single child's fire has the chance to burn brightly tomorrow?
That's a powerful question to sit with. This deep dive definitely doesn't feel like an ending, more like a starting point for thinking about change. For everyone listening, consider what this means for your own community, your local schools. How can we push for learning that truly lights that fire? What part of today's discussion really stood out, really sparked something for you?